As Zoe has said, thank you, Zoe, for that introduction. My name is Sabrina, and I work at a startup called SewerAI. You'll find out in a minute what it is we can do. Maybe you can guess, and then you can tell me, and we'll see if you're right. But at SewerAI, we've been using ClickHouse for a long time, actually, almost as long as the company has existed. And so we have a lot of features that are based on it. We have a lot of lessons learned about ClickHouse, and today we're going to tell you about one feature in particular, and a lot of the lessons we learned there. Hopefully there'll be something that you guys can take home with you that will be useful, so you don't have to go through the same thing that we did. So let's get right into it. What is it that we do at SewerAI? I apologize for anyone who's still eating. Who wants to do that job? Show of hands. Yeah, I gotta tell you. Huh?
How much does it pay?
Pretty good, actually. It's because, yeah, exactly. No one wants to do it, so it does pay pretty good. Not as good as software engineer, but it is up there. But yeah, I have to say, in all my time at SewerAI, I have never had anyone tell me, hey, your AI is stealing people's jobs. Does not happen in the sewer industry. They are very happy that we're here. A question I get a lot when I tell people, I build software for sewers. People start to ask, okay, why do sewers need software? And the reason sewers need software is maybe you've seen out on the streets, truck parked by a manhole, little orange cones all around. You've got a couple guys standing over the manhole looking down like this. There's a cable going down. So what those guys are doing is they are inspecting the sewer. What you do is, you drive up with your truck, hose down, open up your manhole, stick a water hose down there, hose it down best you can. And then what you do is you send down a robot with a camera. Hope you can all see Wally there with his camera. And what Wally is going to do is he is going to collect video footage of all of the sewers in the city. Like, this is a pretty much non-stop job. They're driving around, videoing all of the sewers. And that ends up with, leads to hours and hours of video footage of the sewers. Yeah, you thought your Netflix recommendations were bad. And yeah, somebody has to watch those videos then, just so they can go, hey, there's a crack there. Hey, there's tree roots there. Wow, there is a lot of water, hopefully just water, in this pipe. And what are all these rats doing here? And then the municipality, which if you know municipalities, you know they're usually pretty strapped for cash. Based on those inspections, they're going to have to decide who gets their sewers fixed. So that's actually what a sewer inspection is just collecting this video and then deciding which parts of the sewers you're going to fix. What our founders at SewerAI asked themselves was, hey, why do humans have to watch these videos? Why can't AI do that? It's really boring, and you have to identify consistent patterns. Sounds like a perfect job for AI, right? And so that's what they started doing. That's where ClickHouse came into the picture. We had loads and loads of data, and we wanted to use it to train AI to identify problems in video. That's what we started using ClickHouse for. And it works really great, but that's actually not what I'm going to talk to you about today in this presentation. I'm going to talk to you about a different feature. So the feature that we're talking about is a lot more basic than AI. See, because when our founders came in and said, we're going to apply this high-tech, ultra-modern technology to the sewer industry, what they didn't realize was the sewer industry didn't just need high-tech. They just needed tech. Like, it's a very niche industry. They've been pretty underserved historically by the tech industry. And so we were seeing things like DVDs of videos, storage containers full of CDs, There's a city that shall remain unnamed, but it is nicknamed after fruit, which still uses fax machines in their sewer department. So it wasn't just about AI, it was just about like tech. And especially a big problem they had, AC is kicking in, problem they had also is a lot of the sewer workforce is actually going to retire in a couple of years. The average age is pretty high. Gen Z is coming in. Gen Z does not know how to use fax machines. You have to ask ChatGPT to explain it to them. And so that's what SewerAI started to build besides just AI, was simply a cloud platform for the sewer industry. And so I'm going to show you now our structure. Yes, I got the order of the slides right. So this is our basic structure, very, very high overview of our product. You've got on the left here our customer platform, where users can upload video into the cloud. They can look at their sewer inspections. You've got maps where all of the pipes are. You can see what your inspectors are doing. You can export data. So it's really a modern solution that's appropriate for 2025, unlike the closet full of CDs that one customer has tried to talk us into loading into the cloud. Yeah, this is just sewer for the modern age. This is actually not using ClickHouse. This is using a good old Postgres relational DB. Hey, if it ain't broke, don't fix it, right? Classic, works really well, reliable for everyday use. Problem is, and I think this is something I've heard from a lot of people just chatting in the hour before, it's not quite fast enough. Because one thing we offer also in ClickHouse is live analytics. Say you're a city municipal worker, you've got a meeting in half an hour, and based on the last 9 months of data that you loaded into SewerAI, you need to make a case that you need more trucks, let's say. And so you don't have time to run a query across 9 months of data, 40-odd relational Postgres tables just to collect your information. You need your query to run, and you need those answers now. Hence our live analytics page, part of the product based on ClickHouse. That's what we're going to talk about today. So specifically, we're going to talk about two things. First of all, how do we go from Postgres to ClickHouse? Heard a couple of people who were using Postgres earlier tonight. This is for you, part one. This is going to be, we're going to go pretty fast there because there is actually a very good solution now. It didn't exist when we started, but you really just need to pay attention to the last part of part one if you are trying to do this migration. Second part is we're going to talk about how we formatted our data in ClickHouse so that we could do these live analytic queries. So specifically, our topic of the day, denormalization. If you don't remember what denormalization is, don't worry, we'll do a refresher. So part one, how do we get our data from Postgres into ClickHouse? So Postgres, right, classic relational SQL database, really great, very optimized, awesome, runs under the hood. Everyone knows Postgres, I think. And we're going to take that data and we want to mirror it in ClickHouse. So user makes an update in the platform, that change gets written into Postgres. We want that change to appear in ClickHouse as well. How do we do that? We started out actually with Confluent. Confluent is, pretty great. It's got like a Debezium server to pull out the changes from Postgres, Kafka streams to move the data into ClickHouse. And this was fine right up to the point when we did our SOC 2 compliance, and they said, nope, Confluent needs to go. So our next solution is we decided we're going to make our own Confluent. We're going to do an in-house Debezium server, and we're going to connect them with AWS Kinesis streams. I do not recommend this solution. it does not scale well, and you will spend a lot of time debugging your Debezium server. And so we moved on from this pretty quickly. Luckily for us, we found out about a new product, PeerDB. Anybody here use PeerDB yet? All right, yeah, the guy from ClickHouse, awesome. Oh, and you too. Great, so you know how great PeerDB is, right? PeerDB, really nice, especially if you've been fighting Debezium so far. Basically, you hook up your Postgres and it pulls the data out every second of every day and moves it into your ClickHouse in a set of tables that it has created. Perfect mirror, essentially. So we weren't the only ones who thought PeerDB was really cool. They got bought by ClickHouse. So you know you made the right solution when the database you're using buys your solution. And then they, actually a couple months ago, they came out with a new thing. And if you are just now starting to copy your data from Postgres to ClickHouse, this is where you pay attention. Forget about everything else. You've got your ClickPipes. So ClickPipes built on top of PeerDB for Postgres. Basically, yeah, it's the same under the hood, or almost. ClickHouse guy will correct me if I'm wrong. But this is the solution we are attempting to migrate to. So we did already try to migrate once, ran into a couple of issues I'm going to tell you about at the end of the talk. And this is actually the reason I'm here today, so I can talk in person to the ClickHouse people about this. This is my ulterior motive. But yeah, so this is in progress, but we have achieved our first goal, which is to move our data from Postgres into ClickHouse. Success. So now our data is in ClickHouse. Now what? Now we can use it for live analytics, right? Like ClickHouse is great, ClickHouse is really fast. There's only one problem. We started out with 40-odd tables in Postgres, and now we have 40-odd tables in ClickHouse. And we still need to join across all of those tables so that we have all the data that the query needs. And joining is slow. It was slow in Postgres. It's still slow in ClickHouse. Well, not slow, but not fast enough is the point. And so now we're going to talk about part 2, denormalization. Quick refresher for those of us who haven't had a Databases 101 class in a while. Data denormalization, what is that? Anyone remember?
You basically just put raw data in and you don't care about primary or secondary keys.
That's pretty good, yeah.
Repeat data.
Yeah, repeat data, good point.
But there's also like 3 levels of normalization. When, yeah. So basically, like the latest step is when there's no way to, like, I don't know how to explain it, but
All right, I'm going to stop you there because I'm scared that you know way more about this than I do, and it's going to intimidate me. So for everyone who's on my level of having to Google what denormalization is. So denormalization is when you've got your data in 40-odd tables, and it's all split up nice so you don't have duplicates. You've got your user table, you've got your inspections table. If you're a sewer inspection company, you've got your pipes table, you've got your exports table, and you're not duplicating any information. If I want to modify my user, I only have to go into one table in order to update it. I don't have to go across like 6 different tables because the user information is copied in multiple places. So that's normalization. Denormalization is when you say, okay, so I just really want to load this stuff really fast, so I'm okay with having duplicate information in my table as long as it's all in one place and I don't have to scramble around to fetch it. So what we're doing is we are essentially avoiding joins at query time. And so that's what we needed to do with the tables that PeerDB gave us in ClickHouse. So our first step was actually not even denormalization, it was just preparation for denormalization. We had our PeerDB tables, and then we had our clean tables. So clean tables, you were talking before about JSON data in ClickHouse. So we actually had a step where we were pulling that JSON data out, flattening it into its own columns, formatting it. We're handling nullables. PureDB is particular about nullables, so we had a lot of default information we needed to handle. And the way we did this was with ClickHouse's materialized views. Now, here's your warning for those of you who are just starting out with ClickHouse. Materialized views in ClickHouse are not materialized views in other databases. Same name, different thing. In, say, Postgres, most places, a materialized view, what's that? It's just a query that you stick on top of your table, which sort of pre-computes some of the data so that when you're running the actual query, you don't have to do all of the work. You can just use the pre-computed stuff and be done much faster. And that is not what is happening in ClickHouse with materialized views. ClickHouse goes a step further. So with materialized views in ClickHouse, you're actually going to say, all right, I've got my data over here, I've got my query, and I want to compute this and put it in a different table. So you can actually copy data from table to table using materialized views and apply transforms while you're in progress. I'm saying materialized views here because it's shorter than saying incremental materialized view every time, but this is actually an incremental materialized views, meaning it's always going to check in the original table, what's my new data, what's the increment that just came in, and it's going to apply the query to that and move it over, applying the query to it into the new table. So that's step one. That was our cleaning of the data. And so this is the actual important step. This is the core of the issue. I'm not going to bore you with an explanation of what we were doing before. We had refreshable views because it is terrible and no one should ever have to go through that. But luckily for us, a couple months ago, ClickHouse released a new concept, the refreshable materialized view. And I got to tell you, I love these. These are so great, they're so clean, they're so nice. Refreshable materialized views, and I'm saying refreshable views because refreshable materialized views is a lot. Refreshable views allows you to do a query across multiple tables, including our joins, wrap them up, and then put the result into a single table. In our case, this is our mega table. As you can tell by the name, it is quite big. The mega table is our denormalized state that we want to reach. This is a table that is feeding our analytics. So if you're a customer of ours, you run your analytics, you pull up your data from the last 6 months, boom, your query goes against mega table, single table, 400 rows, lots of duplicate information, but we don't care because it is fast to query. And what the refreshable views do for us is that they can actually be set on a timer, and they can append or not append data, and just pull data from a query every minute or every 5 minutes, every hour, and put it into the mega table. And so this is our denormalization process. This is what we do. So, quick recap. We're in ClickHouse. We started out with our PureDB tables, which PureDB kindly created and populated for us. We've got every minute, we've got new data coming in from the customer side. We pull that data through some materialized views into some clean tables, just to pre-format it and get it ready. And then we're going to apply a refreshable view that is going to join all of our clean tables and put it into one giant denormalized mega table. And we're done, right? Yeah, not quite. So this is very simplified, by the way. We have way more tables and way more views than this. This is just like a schema, just to give you an idea of what we're doing. The actual reality is, yeah, so this is as much of the query as I could fit onto the slides. This is what, 20 lines? The actual query is over 1,000 lines long for our refreshable materialized view. But we're going to go through it, and we're going to talk about some optimizations we can do to make sure that this runs really nicely. I just specifically, why is this slide here? All right, yeah, I'll just roll with it. I will specifically draw your attention to this section of the join. And again, this is not all of the joins, but you can see we've got our clean tables here, and we are denormalizing the crap out of this, pardon my French. We're just joining the stuff all over the place so that we don't have to do it at query time. We suffer so our customers don't have to. So what are the problems that we've had with our setup so far? The problem is essentially that these refreshable views, not just the refreshable views, but our entire system is quite computationally expensive with all the copying and joining and inserting. And so for our price tier, our compute capacity is pretty much always at limit. I'm sure ClickHouse would love it if we were to upgrade to a new tier and pay more, but unfortunately management's not going to go for that. And what this compute capacity limit meant for a long time was that every time that a customer did a particularly large operation, maybe you're uploading 1,000 videos, maybe you're editing all of your inspections at once, this is going to cause a tidal wave of data coming into Postgres through your PeerDB streams into the PeerDB tables, and then it is going to smash into those views and overflow the compute capacity. And this was causing updates to fail. It was also causing backlog to build up, because remember, when the updates start failing, there's still data coming in behind there. So it's like the data equivalent of a traffic jam. You got one accident, and then everybody sits in traffic for 2 hours waiting to get past there. And what this meant was essentially that our analytics were getting out of date. Not good, especially when the customers notice. It takes a lot for customers to notice. So when they notice, you know you've got a problem. So, yeah, and it's only getting worse, right? Because we're a startup, we have to grow, we have to get more customers. More customers means more data. More data means more tidal waves. More tidal waves, we are just breaking that compute capacity. These are the charts that management has allowed me to show you. Couldn't get anything with costs in here, but you can see sort of our data growth over time. Especially the past couple of months, we've had a lot more activity, a lot more reading and writing as well, and this meant that we were having these compute issues more and more often. So, we've established a problem that we're trying to solve. Now let's solve it. First of all, I'd like you to admire this beautiful header for the refreshable view. Again, I love these refreshable views. They are beautiful. Thank you, ClickHouse. So we've got our view defined up here, and then we're saying every minute you're going to refresh. You are going to append. You can refresh your entire database, your entire table if you want. You don't need to append, but at this point we're actually also, yeah?
Is that in Postgres or in ClickHouse?
This is ClickHouse. Yeah, it's you're not going to find this in Postgres, I don't think. This is very nice ClickHouse. At this point, you should know we're also using the mega table as a history table. So we can't afford to drop or lose or restart anything. We are just appending more and more data. It's a couple 100 billion lines at this point, and it only gets worse from here. And so our refreshable view is feeding our mega table. So now you know what a ClickHouse view definition looks like. And so the first thing we did is ask ourselves, okay, why are we running our queries on the entire database if we're really only interested in the new stuff? And by new stuff, I mean the stuff that's come in since the last time we refreshed. So this was a first optimization that did really a lot for us. We're refreshing every minute, every 60 seconds. Therefore, we're going to be generous, and we're going to say, all right, we're just going to query the last 70 seconds of data. Sometimes we need an extra 10 seconds, right? So that was first optimization. Second optimization, for those of you who are new to ClickHouse, this right here, you know what this is? Order by? Yeah, do you want to tell us?
Where we're just doing stuff. Primary key.
Exactly, yeah, that's the index. This is how the primary index in ClickHouse works. A little bit different than other databases, I'm just saying it for the people who are just starting out, but definitely set this. It will really help. We've also got projections, and so projections in ClickHouse are what materialized views are in other databases, but they already use the name materialized views, so they had to call it something else. I think that's what happened. So projections will do some pre-computing on your table so that when you're actually doing the querying, you don't have to do it all the way. You can use your projection. And projection's a little bit expensive, so don't put too many, but used wisely, they can really help also. So what we did is we basically went through all our clean tables and applied a bunch of projections, and that was very helpful with our compute cost problem. Next, now we gotta look at sort of the root of the problem. Joining all these tables. Joining is not fun, but you gotta do it, right? If you're gonna denormalize, you gotta do the joins at some point. First, I would like you to notice that we have different types of joins. We've got inner joins, we've got left joins, and we've got any joins. If you're not a big database person, don't worry about it too much. This is very nerdy. But what ClickHouse will tell you in their docs is that left any, it is allowed, but it is not recommended. Instead of doing left any, you should use dictionaries. So dictionaries, again, they're pretty common data structure in computer science. You've got your key, and your key is going to be the thing that you were joining on before. And then you've got your value, and that's the thing that you were trying to get when you were joining. But dictionaries, much more efficient than left any joins. So if you can, really replace left any joins with dictionaries. All right, databases 101. When you are joining two tables, which side does the smaller table go on? Come on, guys. This is databases 101. The smaller table goes on which side of the join? It goes on.
ClickHouse is the right. ClickHouse is the right.
Yes, it is the right. In general, it is the right. You want your big database to join on your smaller database. And that is something I think we forget a lot with databases that offer under the hood optimization. But it generally does make a difference if you reorder your joins. That was a very discovery moment we had. That's something we hadn't been doing. Also, if you're feeding your tables with PeerDB, bear in mind, some tables grow faster than others. So sometimes it helps to check every once in a while what your table sizes are and maybe reorder your joins. And so now we're getting sort of into the more occult part of the presentation. This is the part where I tell you stuff so you don't have to find out on your own. Would anybody like to tell me what most databases, what is an order by limit 1? What is that database operation? Yeah, this one is really.
Last record by.
Yeah, exactly. So that's what you said exactly right. That's actually a distinct operation, distinct query. And ClickHouse does actually have the distinct keyword. It just turns out that sometimes it's faster to do order by limit 1 than it is to do a distinct. So if you're using distinct in your queries and you want to speed up, maybe give it a shot. Try out order by limit 1. And that's really something that we just stumbled across accidentally, but it's kind of cool. And so finally, this again comes from me as a software engineer being extremely spoiled by relational databases that do a bunch of optimization under the hood. Generally, when you join and filter, for example, in Postgres, they will be very nice to you and filter first and then join. ClickHouse is not going to do that for you. If you tell ClickHouse, join and then filter, they will join and then filter, which means you are doing a very, very large join and then throwing away half of that data. So don't be me, filter first and then join. Especially filter your join key. You can really, I think this was like a threefold increase in speed at half the compute cost, something absolutely ridiculous, but filtering first really makes a difference. So, to recap, our optimizations to avoid having problems constantly with our compute costs was 1, moving in, copying only what we need, apply those timestamps. 2, indexes and projections, have some pre-compute done. 3, replace your dictionaries, your left any joins with dictionaries. 4, order your join tables. I know it seems stupid, but bears reminding. 5th, if you've got distinct, maybe try out a limit 1. Could help. And 6th, for the love of God, don't be me, filter before you join. And let's see what the results are. So in the past 3 months, we started working on this, about 3 months ago, because it was getting untenable. So on the customer side, we had a threefold increase in the amount of data that we were storing, and we had a 10-fold increase in the number of rows that were being read and written. So lots of new data coming in, lots of new customer activity. However, at the same time, our compute usage remained stable. We didn't have any more failing updates. And because we didn't have failing updates, we also didn't have backlogs. And therefore, our analytics were up to date and our customers were happy. Except when we were doing experiments with ClickHouse, and then sometimes we had problems, but that was an us problem. And so now looking at future challenges, just to wrap this up a bit, we do have our migration to ClickHouse to look forward to, and we will be having a talk about this after I'm done here. So if you're just starting out and you've got greenfield ClickHouse database, I really wouldn't worry about this. If you are moving from PeerDB like us, bear in mind the views do not react kindly to being shifted. So this was a problem that we faced when moving our views over to new source tables, something that we are actively working for with the very kind and reactive ClickHouse people, though, the very patient people at ClickHouse. Secondly, even though the scaling issue has been staved off for now, we will probably be looking at it again in the future, particularly as we move to do more things with the data, new features. We've been experimenting with aggregate tables, which is a separate talk that I'll leave for my coworker who's working on this topic right now. But we are looking at ways that we can scale this without breaking things. And third, keeping costs in check, as always. I think this is a problem everyone can understand, unless you work for a FANG, and money is not a problem for you, lucky bastards. So that is what we at SewerAI are doing with ClickHouse for our live analytics. I hope that you learned something, if not about ClickHouse, then at least about sewers. And that you have something that you can take home to apply to your queries. My email is there. I'm also on LinkedIn. I'm the only Sabrina at SewerAI. So if you've got further questions, definitely follow up, reach out. Love to hear from you. Thank you very much.